Hey class, today we're going to be continuing our work with solving quadratic equations in lesson 5.3, and lesson 5.3 day 2's learning goals involve these three things. First, finding roots of a quadratic using special factors. So we actually said in the last lesson that roots is another way of saying solutions, and so we think about that in terms of when we're talking about equations. When we're talking about functions, we call them actually x-intercepts, or we call them zeros, because they actually represent where the graph of the function crosses the x-axis. So a root is another way of saying finding a solution to a quadratic equation. So using special factors. So we'll be looking at those special factor patterns of the difference of two squares and the perfect square trinomial. So next we'll be writing a quadratic function with the given zeros. So if we're told what the zeros are, then we want to work backwards and write a quadratic function that would be associated with those solutions. And finally, find a maximum or minimum height of a projectile, in this case of a ball. We're going to look at an example that specifically focuses on the projectile motion of a ball. So we said we're going to use those two special factor patterns, the difference of squares and perfect square trinomial. So I want to just do a quick review of the difference of squares. So here's an example of a difference of squares. 4x squared minus 36. So that's a difference of two perfect squares. Difference meaning it's subtracted and they're both perfect squares. And so when I factor a difference of squares, the binomials are nearly identical. The only thing that's different is that the binomials will have different signs. One will be a plus and one will be a minus. But the actual terms of the binomials will be the same, and they actually come from square rooting those two perfect squares. So the factored form of 4x squared minus 36 would be 2x plus 6 and 2x minus 6. So the perfect square trinomial was a little trickier because, first of all, it was a little harder to tell. I mean, at a glance, you can tell a difference of squares. You've got, what perfect squares look like, and you've got a difference. But perfect square trinomial, you have to dig a little deeper to make sure it actually is a perfect square trinomial. But then the factor pattern actually is found similar to what we did with difference of squares, but we square root the first term and the last term, and then the sign of the binomials will be identical, and they actually come from the center term. So in other words, say I have something like this. The first thing I'd have to do is make sure that I actually had a perfect square trinomial. So if I wanted to test that, kind of go off to the side over here and I'd see, what is the square root of 4x squared? And I can see that that's 2x. And then I'd look at the last term, which is the 9, and I'd see, okay, is it a perfect square? Okay, if so, what are the square roots? Square root of 9 could be 3 or negative 3. And so in the same thing with the 2x, it could be plus or minus. And so then the test then comes from multiplying these and doubling them and seeing if I could get that middle term of negative 12x. So if either one of these was the negative version of the square root, then I could get a negative. So let's see, if I did 2 times x times 3, that's 6x, double that, that's 12x, or I could get negative 12x. And so that this one is a perfect square trinomial. And so then all I have to do then to find the two binomial factors, I've already done the square roots, and so the binomials will have these as the two factors, the 2x and the 3, but then to find the sign, we actually take whatever the sign of the middle term is, and that'll be the sign of both of these binomials. They'll both be minus. And so another way to write that is 2x minus 3 squared. Okay, so let's take a look at putting this into practice in a couple examples. So example 3a asks me to find the roots of the equation by factoring. Well, actually, I want to take a look at this in two different methods. So we're gonna do one method by factoring, and then I'm going to show you another method. Now actually, in this instance, in this example, factoring may not actually be the easiest method here, because if I had something like, 4x equaled 25 and I wanted to find the solution, that would be like a linear equation. We would just simply divide both sides by 4, and that would give us our solution. Well, we really only have one step further with something that's like this, 4x squared equals 25, and that is to then, that last step, to take the square root. So I'm going to do that, just so use that method here of dividing both sides first by 4, and then I get x squared, and that 25 divided by 4 is 6.25. And so then my last step to find that solution is to take the x squared equals 6.25 and take the square root of both sides. Now when we take the square root, there's always a positive and a negative possibility as long as we have a positive real number. And so when I take the square root of 6.25, I get plus or minus 2.5. And so that's those are my possible solutions. There's 2 of them. Pretty much so far all of the quadratic equations we've seen have had 2 solutions. It's just that these happen to be just opposites of each other. Now if I had wanted to do this problem by factoring, what I would have had to have done is get all of the terms on one side together and 0 on the other, because I have to use that zero product property when I factor. So I would have subtracted 25 from both sides, and I would have turned this equation into something that looked like this. 4x squared minus 25 equaled 0. And then I could factor this difference of squares like this by square rooting both those terms. One of the binomials will be plus, the other one will be a minus. 2x plus 5 and 2x minus 5. And then I could just simply set each one of these binomials equal to 0. So I could just say 2x plus 5 equals 0 and find that solution, and 2x minus 5 equals 0. In the first one I would subtract 5 from both sides and then divide by 2, so that gives me a value of negative 5/2 or negative 2.5. And then I could have done it over the second equation, adding 5 and dividing by 2, so that would give me the x equals positive 2.5. So I get the same solutions, but it just appears like in this case that the factoring wasn't as efficient as the other method. So feel free to use either way when you have something like this. Okay, so let's take a look at example B. Now notice here there's not a whole lot of space for working. But anyway, so if I wanted to solve this by factoring, the first thing I'd have to do is rewrite this so that everything is together on one side of the equation and 0 is on the other side. So in other words, I'm finding the zeros or the roots. And so I could subtract 18x squared from both sides, but the only reason I don't really want to do that is because I don't like to have a leading term that's negative. So instead what I'm going to do is I'm going to take the 48x and the negative 32, and I'm going to bring them over to the other side with the 18x squared. And that will make it look like this. 18x squared minus 48x plus 32. And that's supposed to equal to 0. So right away I saw, there's a greatest common factor for all these terms. So I'm going to go ahead and take that out, and it's a 2. So I could take out the 2 and factor it out, and that leaves me with 9x squared minus 24x plus 16. So then I noticed that the first and the last term, 9x squared and 16, looked like they were perfect squares, and in fact they were. And so I started kind of thinking, well, maybe I had a perfect square trinomial. And so I did a quick test on that part in the parentheses, the 9x squared. The square root of 9x squared gives me 3x, or plus or minus 3x. And then I took the square root of the 16, and that gave me plus or minus 4. And I did that quick test on the middle term where I multiply the 3x and the 4, and I double it, and I would either get 24 or negative 24. And so that middle term matches, it works, and that means this one is one of those perfect square trinomials. So I could break that part down into 2 identical binomials that have the factors of 3x and 4, and the sign's going to come from the middle. It's going to be a minus. And so the factored form of this is actually 2 times 3x minus 4 squared. Well, that 2 out in front is really not doing anything to the solutions at all, because I could actually just divide it right off, and it would do nothing to the 0. So if I divided both sides of the equation by 2, then that's actually going to leave me with 0 equals 3x minus 4 squared. And I only really have one binomial. I actually have the same binomial twice, which tells me I'm really going to only get one solution to this. This is going to be one of those parabolas that's actually just sitting right on the x-axis with its vertex there. So it's only crossing one point, and so the one solution is going to be the one that makes this equal to 0. So I could just set the 3x minus 4 equal to 0. I'm going to add 4 to both sides, and that gives me 3x equals 4, and divide both sides by 4, which gives me x equals 4 thirds. So there's just one solution here, and it is 4 thirds. Okay, let's try one more. And it's funny because example C has so much space and it's a much easier equation to solve. So I think we maybe need to flip-flop these for in the future. But anyway, so we want to find the roots of the equation by factoring of x squared minus 4x equals negative 4. So the first thing I'm going to do is put this in a form where everything is on the same side. I'm going to add 4 to both sides. That leaves me with x squared minus 4x plus 4 is equal to 0. And I noticed right away that this was one of those perfect square trinomials. And so I'm going to go ahead and factor it into x minus 2 and x minus 2. And that means since their binomials are identical, there's just one solution. And that solution is x is equal to 2, because 2 will make both of those binomials equal to 0. So there's just one solution. It's x is equal to 2, or one root. So the root, or the solution, as we call it, is negative 2. All right, so I'm going to have you give D a try. This one's very similar to example A. So we're going to do this one as a you try question, and you could use either method, or both, I guess, if you'd like to, as A. So you might want to, again, look up here, and A is one that's very similar to this one. So pause the video now and solve 25x squared equals 9. All right, thanks for trying that one. Hopefully you got x is equal to 3/5 and x equals negative 3/5. And again, if you didn't, be sure to make a note to bring up in class the next time we meet. So let's go ahead and turn the page. Okay, so in these next two examples, we're going to take what we know about the zeros of a function and see if we are actually given the zeros or the solutions to a quadratic function, if we can work our way backwards and get a possible quadratic function that might have been the solution to. In other words, write the quadratic equation or function that goes along with the zeros. So we'll do one together, and then I'll leave you one for a you try. So this one says write a quadratic function in standard form. Notice it says a quadratic function. It's going to turn out that there's infinitely many possible ones that we could write. But we're going to write the simplest one, is the one that we're going to write. So we're going to write the simplest quadratic function in standard form with zeros 4 and negative 7. So if we think about how we solved quadratic functions, we factored them, and then we took the two binomial factors and we set them equal to 0. Now we're kind of working backwards. We know the zeros, we want to get the binomial factors. So if I had a solution of 4, it must have come from the binomial x minus 4, because if I put 4 in for x there, it would give me 0. And so I know that a 0 of 4 is associated with a binomial factor of x minus 4. And if I had a 0 of negative 7, or a root of negative 7, it must have come from a binomial factor of x plus 7, because if I put that negative 7 in for x, it would make those binomials equal to 0. Okay, so now all that's left to do is to just multiply out these two binomials using our FOIL process. So we multiply the first two, we get x squared. The two outside ones, we get a positive 7x. The two insides, we get a minus 4x. And the two last is negative 28. Group our like terms together, and we get x squared plus 3x minus 28 is equal to 0. And that's the simplest possible quadratic function that would have those two solutions. Now there are more complicated ones that would come from if we just say took everything in that equation and multiplied it by 10. It would be 10x squared plus 30x minus 280. Or if we multiplied it by any scalar value, that would just give us basically the same equation with just larger, proportionally larger coefficients. So the simplest one is the one that we're looking for, just the one that actually would have a leading coefficient of 1. So as usual, I want you to try one. So we're going to make B the you try question. So pause the video now and write the simplest quadratic function in standard form with the zeros of 5 and -5. Pause the video now. Okay, so if you're tuning back in, I hope that you got x squared minus 25 equals 0. But I actually didn't get the final step in example A to get that function in its actual function notation in function form, and so I want to correct that, and then we'll come back down and we'll actually do the final step for B. Because what I really should have done is I should have taken this, and if I wanted to write it as a function, I have to replace 0 back with f of x. So I really should have written it as f of x is equal to x squared plus 3x minus 28. And that really should have been my final answer. And what that means in terms of example B is we should have done the same thing, and we should have rewritten this as f of x is equal to x squared minus 25. And that would have been our final answer in function notation. So as I mentioned before, this is just an example of one possible quadratic function that has these two zeros, and that note just kind of expands on that a little bit. There are many quadratic functions with the same zeros, and so I gave some examples. So example A, B, and C, x squared minus x minus 2, negative x squared plus x plus 2, so notice how all the signs were just changed, and then C, 2x squared minus 2x minus 4. That's where they just took the function in A and multiplied everything by 2. Those will all have the same solutions. They all have the solutions of 2 and -1. So writing function rules using zeros does not give a specific function, like there's only one specific one. It just gives one of the possible ones. So this, when we're giving these, it's not an exact, like this one has to be this one. You certainly could be, creative and take your equation and multiply it by like every number by 1.5 or by -27 or whatever. But the most common one is going to be the one that's in the simplest form, the ones that we did here. So let's go ahead and turn the page. All right, so we have reached our final learning goal, and this was the one where we were going to see if we could find some information about a projectile like a ball and find information out about it. So any object that is thrown or launched into the air is a projectile. Now the general function that approximates the height in feet of a projectile on Earth after t seconds is given. The formula below does not account for wind resistance or other real-world factors, though, but let's take a look at it. So the formula says that the path of a projectile near the Earth's surface of the Earth can be approximated using the formula, and again, not accounting for wind resistance or other real-world factors, but can be approximated by this formula: h of t, height, and t is time. So h of t is equal to -16 t squared plus v sub 0 t plus h sub 0. Now what those things actually mean, well, the -16 is the constant due to Earth's gravity in feet per second. So that -16 is a constant value that was calculated that approximates the effect that gravity has on an object. Now the v sub 0 is actually specific to the whatever the situation is, and it's the initial velocity. It's also measured in feet per second. And then the h sub 0 is the initial height So that sub-zero means at the starting point. So that v sub-zero means the initial velocity, and h sub-zero means the initial height. The height, when the projectile is starting. So here's an example. A golf ball is hit from ground level with an initial velocity of 80 feet per second. Okay, so if we were to take that 80 feet per second, that's the initial velocity, that actually goes right in for that v sub-zero. And it said that it was hit from ground level. So that ground level actually tells me that the h sub-zero must be 0. It's starting right on the ground. So that's supposed to be the height above the ground, and so if it's on the ground, it's 0 feet from the ground. So we're going to start with an initial height of 0. And we want to know after how many seconds, that's t, time in seconds, will the ball hit the ground. So in other words, when we've hit it off the ground, now it's going to go up in the air, travel along like a parabolic path, and that's going to come back down and hit the ground after so many seconds. And we want to know how long is that. So let's take a look at the effect of substituting 80 in for v sub-zero and 0 for h sub-zero. All right, so I went ahead and plugged in 80 for v sub-zero and 0 for h sub-zero, and that made this equation specific to my situation of hitting this golf ball, and it's negative 16t squared plus 80t. Well, so again, this golf ball starting on the ground, and it's hit in the air. It's going to reach a certain highest point, and it's going to come back down and hit the ground. And we want to know when does it hit the ground. So what we really want to know is when is the output or the y value equal to 0. So we're going to substitute in 0 for h of t for the height. And so really again I've got these two terms, and anytime I think of two terms, I think of either difference of two squares, or I think of just is their greatest common factor. So I'm going to see if there's a greatest common factor to negative 16 and positive 80, and in fact there is. So if I were to take out the greatest common factor of negative 16, and I like to take out a negative if the leading term is negative, but they also have a t in common. So I could take out a negative 16t. If I divided that out of the first term there, I would be left with t, and out of the 80t I'd get minus 5. And so that means that my two possible solutions are the values that make negative 16t equal to 0 and the one that makes t minus 5 equal to 0. So that means negative 16t is equal to 0, or t minus 5 is equal to 0. And if negative 16t were equal to 0, then t would have to be 0. Now that actually represents the place where the ball was starting. And if I solved the other equation, I'd have to add 5, so I'd get t is equal to positive 5. And that's the one we're looking for. That's the one that's going to show me where the golf ball hits the ground. And so I know my answer is 5 seconds. So that's going to be when the ball hits the ground, is after 5 seconds. And that's my answer. So I'd like you to go ahead and do the exact same thing and do the you try question for B. You try question. A football is kicked from the ground level with an initial velocity of 40 feet per second. How long is the ball in the air? So just follow this one as an example and find the solution to tell how long the ball is in the air. That means how much time has passed from when it was initially kicked and when it actually hit the ground. So pause the video now. Okay, so your answer is 3 seconds, and that's going to do it for our lesson today. So again, make sure you go back through your notes, see anything that you're struggling with still, and make note, and we'll address those issues when we meet in class. So I'll see you then.